Welcome to this session. My name is Axel, and actually this morning my throat and voice decided to give up on me, so sorry if I crack up. But it's actually pretty cool because you can make things like, I'm Batman. So yeah. Okay, so we'll be talking today about how to make smooth transitions inside of Unreal Engine 4. We will cover different approaches for both solo player games and multiplayer games. So I am French, but actually I've been living in Japan for more than 6 years now. I work at Epic Games Japan. And before joining Epic, I shipped a couple of Unreal Engine games. I've worked on series including Naruto or No More Heroes. So if you've played some of them, thank you. So my work at Epic Games is a support engineer. What that means is basically when one of our licensees have a problem using Unreal, be it a feature, a bug, or just wanting to get the most out of our tools and doing things for profiling and optimizing, we help them. So it can be made online using UDN, as I'm sure many of you guys use, or we can actually go to our site and help them right at their studio. That's something we can do in Japan because pretty much every game company is located in Tokyo, so it's very easy to move. So on my spare time, I've been learning assembly because I was not listening in school. I was playing Monster Hunter on my PSP, so I kind of regret it now. But yeah. So actually, if you're very serious about how you're fetching your instructions to your CPU, I would highly recommend giving assembly at least to understand it. It will really help you to debug things on very low level. And on my spare time, I'm also playing Kingdom Hearts 3, which has actually been made using Unreal Engine 4 in Japan by Square Enix. It's an amazing game, and actually I think it's probably the best example of how you can really scale Unreal Engine to AAA, or even in this case, quadruple A games. It's a pretty cool game. You should definitely give it a try. So let's get started. What you will learn in this session, well, first of all, we'll be talking about something I really love about the Unreal Engine, which are modules. Everybody should use modules. We will also talking a lot about threads, about multithread, about how it's being handled inside of UE4, and how you can leverage them to make beautiful and smooth loading screens. And also, we'll have a quick overview of one of my favorite functions and features inside of Unreal Engine that is not so well known. It's called seamless travel, and it's really a lifesaver when you want to do some smooth transitions inside of a multiplayer game. But at the same time, what this session is not. It's definitely not a deep dive into how threads work inside of UE4. 45 minutes would never be enough to do so. And it's also definitely not a full tutorial on how to build a loading screen inside of multiplayer games. So basically, I've made these slides not for you, but for me. For me 2 years ago, when I was working on a game and my manager told me, okay, you're going to be making the loading screen for No More Heroes. And I was like, okay, sure. I will Google some documentation, and I'm sure Epic will have some cool doc, right? Turned out it was pretty scarce. So actually, this is exactly the kind of starter guide I wish I had 2 years ago when trying to tackling these problems. So I hope it will help some of you guys. So first of all, we'll be talking about the solo player approach, so asynchronous loading screens. And we'll be talking about many concepts, but first of all, we should have a quick introduction about what is multithreading and how is it implemented inside of an Unreal Engine. To keep things very, very simple, it's obviously not this simple, but really, multithreading, it's basically just the ability to make multiple calculations on the same processing unit. But depending on hardware, so on the type of CPU, but also on the OS layer of a system, multithreading can really mean very different things. So when you're making a multi-platform game, you really have to understand how multithreading is being handled by every platform. Otherwise, you will get beaten very hard. So always test very thoroughly every asynchronous call for every platform that you're shipping on. But inside of UE4, so multithreading, actually, even if you've never used it, you're actually using it, because Unreal Engine is using threads very heavily. It can have like 10 or even 15 threads running at the same time. I think the best example of it is when you're using the common stat unit, and when you get your top right corner of your game, the screen you have there, with a frame, game, and draw to basically get all of the performance of your current frame rate for your game. Actually, game and draw mean game thread and draw thread, and you can obviously add as many threads as you want. And for more regular and a basic asynchronous task in the engine, I will recommend using and searching for Async task inside of your Visual Studio solution. Definitely put a few breakpoints inside of how it's being implemented inside of the engine. It's pretty useful. So now about loading screens. Well, what is a good loading screen? First, I would say that it's short, but not too short though. I don't know about you, but when in a game, there's like a hint displayed in a sentence, and actually can't even read to the end of a sentence, that the loading screen is already gone. It pisses me off. So you should have like a timer in a good loading screen logic, right? To be able to manage at least the number of seconds the loading screen has to be displayed. A good loading screen would also have good performance and be smooth. So by this, for example, if we have a spinning animation, so like this. So let's say it's running at, I don't know, 20 or 30 FPS. This is decent. This is probably enough for loading screen. But on many games, what you see is actually that, right? Running at maybe 4 or 5 FPS. So you might say that it's not really relevant for just a spinning animation, but I personally think that loading screens are a good opportunity for your artist to shine and to maybe show cool concept arts about the world of your game, or about showing quick-ass video. And in this case, well, good performance is actually very relevant. So you should have good frame rate inside of your loading screens. So now about how it's implemented inside of UE4. First thing you have to know is that all of the level loads operations, they can only be made in the main thread. It's kind of counterintuitive, but what you have to do is actually create a new thread to display the UI of a newly created thread to make it a loading screen, and do all of the level load operation on the main thread. But do this in background. And when it's done, you can bring back the main thread to the foreground and do all of the other assets loading using Async task. So this is what it looks like. This is for ActionRPG, which we're going to talk a lot more about in the next slides. So you're on your title screen, you press Start Game. What will happen then is you will actually create a new thread displaying the loading screen, and you will push this newly created thread in the foreground while you don't display the main thread anymore. And in the main thread, you will do all of the level load operations. And when it's done, you get a notification kicking back in and saying, OK, I'm ready. So then you can stop displaying the newly created thread and go back to the main thread and to your new level. So yeah, we'll be talking a lot about ActionRPG. It's actually a great example for this kind of threading logic, but not only for that. It's actually the epic way of making games. We obviously cannot share with you guys the source code of Fortnite, but still, we wanted to share how we're making games at Epic. So we are using exactly the same design choices for ActionRPG, but we're actually using in Fortnite. So you should definitely check it out and really studying the source code and how we are handling everything in ActionRPG. It's free for download on the Epic Games Launcher, but just make sure to go to the Marketplace tab and not the Learn tab. Otherwise, you will not find it. So this is what it looks like. So you press the Start Game button, and you can see on the bottom right corner, the animation is actually very smooth. You've got good frame rate. So it's doing all the level loads in background in the main thread. And when it's over, you go back, and then boom, you get the level streaming kicking in. And you're on your new level. So this is what is happening. As you can see here, what is important is that there's never one single call from the game module directly to the engine. It's using an interface. And this interface is inside of a module that we're going to create from now on. This is, I think, the best way to have as less side effects as possible. So basically, your game designers will only be calling it in the blueprint or maybe C++. And then the programmer who will be in charge of making the loading module can really talk to the engine, and nobody else does. So now, how to use it? It's pretty simple. So in the case of ActionRPG, for example, in the game instance blueprint, you all know the open level function, right? So before that, from now on, you would only have this fade in and show loading screen function call, which is actually only one call to a blueprint callable C++ function, which is called play loading screen, which is the one we're going to make. So it's very easy. It's just basically one call to make before your open level, so nobody can miss that, right? And just one tip, actually on purpose, I've put as the level name argument of upper level, just the level to load string. This is very bad. Never do that. You always want to use the absolute path for the level name asset, otherwise it will loop in all of your level assets, and it's very bad for performance. So always put the full path of a level asset. I see this many times, and it's like something that could be fixed in like a few seconds. So yeah, sorry for all people, all non-programmers people here. Now start the programmers talk. So we'll be talking about modules first. So modules, you have to understand that it's really a fundamental building block of Unreal Engine. Actually, everything in Unreal Engine is a building block, including everything in Unreal Engine is a module, including the game. The game itself is a module, and you can add as many and you can edit as many modules as you want. And this is what we're gonna do. So modules, they have a few merits. So first of all, you can split the logic between the game and the loading, in our case, for loading screen module. So what this means is when you've got your engineer working on the, the level part, and the other one working on the loading part, when there's a new bug in the game, there's very less chance that it will have an impact on the loading. And this is also true the other way around. It's also very easy to manage. And by that, I mean that, especially like for source code-wise, when you have just one person working on the feature, you will have less conflict when submitting your code. It's a lot of time that can be gained. It's also very portable. I think some portabilities, most of the time it's overlooked, but it shouldn't be. I mean, how cool can it be if you're making your game with Unreal, you're shipping, it's selling well, you have a party, everybody's happy, but at some point in time, you will have to make a new game. And how cool could it be if you could just pretty much copy-paste everything you've made as a logic for your past game and just change your assets and be able to use it in your new game? That'd be pretty kick-ass in my opinion. So it's actually a lot of time that you can gain. Also, it's something that I was taking care of, and I know how tedious of a task it can be. Is about updating and merging engine releases. First, you think, okay, it's going to take me 2 or 3 days, and after 2 weeks, you go back to your manager, and you're like you're like face palming and say, "Oh man, I'm never going to. It's just a mess." And yes, it is. Probably never be an easy task, but there are ways that you can make this easier. Is by actually editing the engine as less as possible. So if you're splitting all the logic you can inside of modules, it will actually things a lot easier, in my opinion. And last one, I think that using modules is actually very black box. And actually, when I was having the rehearsal of this talk back at Epic Games Japan, my colleagues told me, and they were true, oh man, you should not use black box. I mean, we are all about giving our developers the source code and always be very open. This is a very, very negative world, a very negative word, and I fully agree. Black box is negative. But it turns out that when you're actually making a game, not everybody wants to know what's happening. And I personally think that it's not the engineer and the programmer are actually not making the game. They're just giving the technological and technical support to the people making the game. And they are the artists and the game designers. So actually, on a day-to-day basis, you just want things to work. You don't want to always know how everything is working. But at the same time, you need to be able to understand when needed. So I think this is why modules are really great. It's just like a black box, but you can actually dive in when needed. So yep, to that extent, I think black box is actually a very good thing. So we'll look over the implementation now. About the folder, it's nothing fancy. It's just that you've got your project folder, right? And after you get your source, and so in the case of ActionRPG, you get the private with implementation files and the public with the headers. So you'll just be adding a new folder for every new module with some C# files for Unreal Build tool. If you want to check the implementation, you can just download ActionRPG. It's pretty straightforward. One thing though, it's about how modules are being loaded inside of the engine. So because we are making a loading module, it has to be initialized before the game, because you can possibly have a loading kicking in even before the game starts. So this has to be defined. This is actually defined by an enum inside of the Unreal Engine called a loading phase type. So just look for it and see all the options you have. I think for loading screen, the one called preloading screen, which is the one right before default, which is the game one, is actually the best. So how to edit that? You just open the uproject file with your favorite text edit tool. Mine is Notepad++, obviously. And you just change default to preloading screen, and you're good to go. So yeah, nothing fancy. So now we'll be talking about the code itself. So the interface is pretty straightforward, nothing fancy, only 3 functions: a get, a start, and a stop. You can really make things easier than that, right? And boom, done. The implementation now. The implementation of the interface child. So I won't look at the 3 functions. We actually will be talking. We'll be doing that later. But just see that we're only like really fitting some arguments to something called on the last line the movie player. And this is the important line inside of this function. Otherwise, it's just a very basic initialization. The big part actually is the UI. And the UI, we're going to be using Slate. Who has ever used Slate here? Cool. So yeah, actually like half or something. Cool. So actually Slate is a custom UI programming framework designed by Epic Games for Unreal Engine. And actually, the editor itself is made using Slate. Nowadays, on the recent releases, we're pushing lots of fancy stuff. You can use Python, you can use Blueprint, you can use UMJ. But I personally think that low-level stuff, C++ is actually very efficient and should definitely be used for this kind of system-related functions. So this is what the widget will look like for Slate. It can look actually quite odd. It's like some CSS styling weird thing. But when you look closely, for example, what's happening in the child slot, or even like the plus S overlay slot, this kind of thing, you don't really see that a lot in C++. But when you really look at it closely, you can see that it's perfectly correct C++. And for example, the plus is only an operator overload. And if you're used to using styling languages such as CSS, actually in a couple of days, you can really be a master of Slate. And for once, we actually have very good documentation about this feature. Some are made by Epic, some are actually made by some other folks, maybe some of you guys. So you've got also tutorials on YouTube and everything. My personal favorite is actually on the Unreal Engine wiki. It's called Slate Hello, so check it out. And now back to the implementation of a module logic. You can see a start, a stop, and a create. Once again, nothing fancy. The only real important lines here are the get movie player. And yeah, that's pretty much it. Actually, now you might be starting to think, okay, man, you sold me this as an asynchronous thing, but you're actually not doing nothing asynchronous here. But it turns out that we are. And the reason is that Slate is actually running on a separate thread. So for people interested, it's actually using RHI. So to get an idea of what is actually being threaded, it's movie player. It's running on the Slate thread. And if you don't believe me, you can look for yourself inside of a movie player threading.cpp file. And I personally think that it's a great example of how you should create and add threads to the threads array inside of the engine. So we'll just have a look at the initialize. As you can see, we're actually creating a new thread, pushing it on the threads array, and this will be a runnable thread, right? And boom, there you go. Smooth loading screen. Maybe you can do this. Okay, let's call it 5 days of work, and you're done for all of the projects of your company. I think really there's no excuse of not making good loading screens, at least for a solo player. So yeah, definitely check out ActionRPG. Now we'll be talking something actually very different. It's called seamless traveling. I've worked on several multiplayer games, and I was not really aware of this feature until very late in production, but it's really a lifesaver when you know how to use it. So what is it? Well, it's a way to move from one level to another in a server-client relationship-based game. And you're coordinating the needed data from the server. And what is important is that it's non-blocking. So what is happening is that when you're actually loading the new level on the client, you're in a transition map where you can do things. It's like a regular map, but only you can use it as a loading screen. It's pretty cool. And you have another very good benefit using it, is that you can determine by yourself which actors you want to keep and which ones you want to let go and be garbage collected. So this is what like a typical server-client relationship looks like. So a server wants to move to the new map, so it will send a signal to every client saying, okay guys, time to move. Client will still be on the old map. And when the loading is done, boom, you get a notification back to the server saying, okay, okay, man, I'm ready to move. And when all the clients have sent the signal, you're moving to a new map. This is how we're handling things in Unreal Engine, pretty straightforward. But what would happen in a non-seamless travel, which is the regular way, is that every time you are connecting every time you're moving to a new map, you have a full disconnect and reconnect to the server. This is really not efficient. It has some merits, which are that you have a clean slate every time. Pretty cool for your data. But you can actually, so if you know how to handle your data and assets, you can really do way better than this performance-wise. So, and this is what seamless travel is. It's like in this in-between state, you actually have a transition map and you have no disconnection from the server. So you're always connected to it. Everybody's moving along. It's pretty cool. So when to use it? I would say actually that's the other way around. When not to use it? You should find an excuse, not a reason not to use it, and not a reason to use it, because it's so easy. But still, you've got some limitations inside of Unreal about when you actually can't use it by design. Well, when you have your first load inside of your game, so when you're going to the first match of your multiplayer session, well, you can't use seamless travel. And the reason why is that you don't have a server. So yeah. And it's also true that when for some reason you actually have a disconnection from your current server and you're switching servers. So you can't use it for this 2 times, and otherwise use it as much as possible. So now let's have a quick overview of how it works. To activate it, nothing can be more simple. It's just you've got an integer. It's called BU seamless travel. Just put this big boy to 1, and you're good to go. You will also need a transition map. And so first, what is a transition map? It's, as I said, a level between the old and the new levels. It's basically made because there is a design limitation inside of UE4 is that to keep actors, you actually need a world. And the easiest way to have a world is to have a level. So this is why transition levels exist. Um, but actually, it's a great opportunity to make, I don't know, things such as a mini game or just having maybe in a very simple map the ability for your player to move or something. If you have to wait for 20 seconds for every client to move to the new map, you should at least, be able to wait for those 20 seconds in a funny way. But definitely keep this transition map as light as possible. Otherwise, it would kind of defeat the purpose. So personally, I wouldn't use sublevels. But let's say that by designing your game, you're like using sublevels to split, I don't know, something like blueprints and lightning and geometry, for example. Well, I think this is a very good idea. But still, for transition map, what you would want to do in that case is in the persistent level, load all of the sublevels by default at start of a level and not doing it in Blueprint or C++. So actually, many games using non-seamless travel are using a simplest transition map possible, which is like this. It's blank, there's nothing. So this is also a very good transition map. The whole point of transition map is actually to keep your data alive. So if you don't intend on creating a mini game or something, I think you should. But if you don't want to, this is cool too. So why should you define it? It's in the project settings in map and mode. You see in default maps, the last one is called the transition map. So you set your transition map here and you're good to go. So now what the whole data flow will look like using transition map. It's first, you're going to mark what actors are to be kept. Then you're going to move to a transition map. This will be handled by the engine. Actually, you don't have to do anything. And then when you're on your transition map, I would definitely check that all your actors are alive and well. And when it's done, and when everybody has done the transition, well, then you can move to the new map. So I'm talking a lot about keeping actors alive, but so by default, using seamless travel on the server side, you have a game mode, the game state, and all the controllers with a player state that are by default being kept alive. You also have every local player controller for both the client and the server. But actually, you can really add as many as you want. It's pretty fun. On the server side, it's in the game mode base, and you've got the get seamless travel actorless function. So as you can see in the if be true transition, if we have the actor list, and we are adding stuff there. So you can add as many stuff as you want here. It's what it's made for. On the client side, it's defined inside of a player controller. So you got the same, a get seamless travel actor list, and then you got your actor list. You can see that it's just an array of actors, and everything you put inside of it will be kept for the new map. But please, please, please don't edit the engine for that. You want to override, you want to inherit, and do this locally on your game. There's no reason why you should edit the engine for this. So you just override it. You don't forget you call the super, and then you can edit the actor list as much as you want. So there's no real drawback to seamless travel. I think that as once written in a great comic book, you just have, great power comes with great responsibility. So let's say that you have really bigger power over the life cycle of your data. Well, then you have to be careful about using it. It's just about always asserting, always checking the life and death, making sure that there's no sec fault that could happen to me. Yeah, just always be very careful about checking the life of your data, and you won't have any problem. And also, that's actually not really related to seamless travel, but it's more about networking in general. It can't be debugged inside of a PIE. So it's kind of a mess, but it's how it is. So personally, when I was working on multiplayer games, what I would do is like on my PC, I will have like 3 or 4 instances of Visual Studio running. I will have pre-cooked all the assets of a game, and I will actually run the game in a debug or whatever using the game arguments on the same machine. And then you can use all the breakpoints and everything inside of your Visual Studio. So when you're used to it, it can be actually it takes some time to set up every time you have to debug something, but it's actually quite efficient, and you're closer to a real game performance than PIE, so it actually has merits. A few final thoughts. Well, in a multiplayer game, you still have single-player loadings, so you can definitely apply, and you can the things we've looked at in the first part of the talk. And also, I personally think that good loading screens will make your players more forgiving about slow server connections or a slow performance, or even if you get like big textures or big assets to load. If your loading screens and transitions are good, your players will probably be happy with that. Okay, thank you.